welcome to our channel Knowledge of. Please subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics, that has been of class 11 part 1, that has been the class 5th. You had done your class 4 and there we have done your physics. What is physics? The scope and excitement of the physics, as well as the fundamental nature of the physics as well, wherein that we had done your gravitational forces, electromagnetic forces, weak nuclear forces, strong nuclear forces, the unification of the forces as well. The fundamentals natures of forces, with the same we have discussed about the physicist with their country of the origin, and the discoveries, the contribution as well. So today we will continue with unit 1, which has been the physical world that we have discussed here. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Today we're gonna start with the nature of physical laws. So nature of physical laws that we discussed here, and the same phase here, that the physicists that explored the universe, their investigation that is based on the scientific processes that range from particles that are smaller than the atoms in size to stars, and that are very far away. In addition to finding the facts by observations and experimentations, physicists attempt to discover the law that summarizes often as mathematically equation that these facts here. On the same phase, that in any physical phenomena that governed by a different forces, several quantities that may change with time, and a remarkable fact is that some spatial physical quantities however remain the constant in time. They are conserved, that the quantities of the nature, and understanding these conservation principles is very important to describe the observed phenomena quantitatively. In the same case, for motion under an external conservation force, that the total mechanical energy, that is the sum of the kinetic energy and a potential energy of the body, is a constant, and the familiar example is the free fall of an object under the gravity. Both the kinetic energy of the object and its potential energy change continuously with time, but the sum of that remains fixed here. If the object is realized from rest, and that the initial potential energy is completely converted into the kinetic energy of the object that just before it hits the ground, and this law restricted for a conservative force that should not be confused with the general law of conservation of energy of an isolated system, which is the basic of the first law of thermodynamics. We'll discuss the progress in the unifications of different forces, domains, and nature, which has been progress in unification of different forces, domains in nature. The name of the physicist then next we have your air, and then achievement in unification, so first we talk about Isaac Newton. The year we have is 1687. Achievement in unification is that unified celestial and terrestrial mechanics that showed that the same law of motion and the law of gravitation that apply to both the domain. Unified celestial and terrestrial mechanics showed that the same law same laws of motion and the law of gravitation apply to both the domain. The next we talk about the Hans Christian Ørsted and Michael Faraday. So first we'll discuss about Hans Christian Ørsted. It is in 1820 that showed that electric and magnetic phenomena are inseparable aspects of unified domain, which is electromagnetism. Showed that electric and magnetic phenomena are inseparable aspects of a unified domain, that is electromagnetism. And now we talk about for the same here is with Michael Faraday. It is in 1830. We're talking about the another one, which has been James Clerk Maxwell. It is in 1873. Unified electricity, magnetism and optics that showed that the light is an electromagnetic wave. And optics that showed that the light is an electromagnetic wave. Now we talk about further another one. Here has been Sheldon Glashow and Abdus Salam and Stephen Weinberg in 1879. Sheldon Glashow, then Abdus Salam, and another is your Stephen Weinberg. That in 1979 that showed that the weak nuclear forces and the electromagnetic forces could be viewed as different aspects of a single electro-weak forces. That showed that the weak nuclear force, and the electromagnetic force could be viewed as different aspects of a single electroweak force. Now we talk about for the next is being about for Carlo Rubbia. We're talking about the Carlo Rubbia here. Carlo Rubbia, Simon Vander Meer in 1984, and that was being verified experimentally the prediction of the theory of the electroweak force, which you talk about it. So with the same we go ahead and that talk about for 1984 here, and that has been the achievements to in unification has been that to verify experimentally the prediction of the theory of the electroweak forces that we have here, and that has been. So with the same in that we have your achievements for verified experimentally the predictions of the theory of the electroweak forces, and that even though we have to discuss here, so we further go ahead and that we complete the progress in unification of a different forces and that a domain in nature as well. So very verified experimentally the prediction of the theory of us that theory of electro electroweak forces that we have here. On the same behalf of it, we talk about here. So we are in a physical phenomena that governed by different forces. As I told you that the several quantities may change with time, and a remarkable impact fact is that the some spatial physical quantities that however remain constant in time, and they are the conserved quantities in of nature. Understanding these conservations, that principle is very important to describe the observed phenomena quantitatively. On the same behalf of it, that we talk about it here, and that for motions under an external conservative and that forces that the total mechanical energy, that is your the sum of the kinetic the kinetic and the potential energy of a body is a constant, where the familiar example of this free fall of an object under the gravity is both the kinetic energy of the object and its potential energy with that change continuously with time, and but the sum of that remains a fixed, and if the object is realized from a rest, and that the inertial potential energy is completely converted into kinetic energy as well as of the object that just before it hits the ground. And this law restricted for the conservative force that should not be confused with the general law of conservation of energy as well. that is of conservation of energy that is being noted, that conservation of energy of an isolated system, that is which is the basis of the first law of the thermodynamics as well. In the same field, the concept of energy is essential to physics and the expressions for energy that can be written for every physical system. When all forms of energy, that is your heat, mechanical energy, electrical energy, etc., that are counted, it turns out that energy is conserved, and that the general law of conservation of energy is true for all forces and for any kind of transformation that between different forms of energy. In the following object example, if you include the effect of your resistance during the fall and see the situation after the object that hits the ground as well here, so we go for the same here. And in the following object example, if you include the effect of resistance during the fall and see the situation after the object that hits the ground and stays there, so the total mechanical energy is obviously not conserved, and that the general law of the energy that conservations however is still applicable. The initial potential energy of the stone that gets transformed into the other forms of energy and heat and sound, ultimately the sound after it is absorbed, that becomes heat, and that the total energy of the system that is being stored plus the surrounding that remains unchanged. The law of conservation of energy is thought that to be valid across all domains of nature, where from the microscopic to the macroscopic, it is routinely applied in the analysis of atomic, nuclear, and elementary particle processes, as well as, at the other hand, all kinds of violent phenomena that occurs in the universe of all the time. Yet the total energy of the universe, that the most ideal isolated system possible, is believed to remain unchanged until the advent of Einstein's theory of relativity. The law of conservation of mass was regarded as another basic conservation law of nature, since matter was thought to be indestructible. It was and still an important principle that has been used, for example, in an analysis of the chemical reaction. A chemical reaction is basically a rearrangement of atoms among different molecules, and if the total binding energy of the reacting molecule is less than that of the total binding energy of the product molecules, and that the different appears as heat and the reaction is exothermic. The opposite is true for energy that absorbing the endothermic reaction as well. On the same phase, that however, since the atoms are merely rearranged but not destroyed, where the total mass of the reactants is the same as the total mass of the product in the chemical reaction, wherein that the change in the binding energy are too small and they are measured as changes in mass as well. We are on the same phase, that according to the Einstein theory, mass m is equivalent to the energy E, and that is given the relation, which has been the relation as your relation has been given like E equals to mc square, and where c that is being here is being the speed of the light in vacuum. C is the speed of light in vacuum. So we are in a nuclear process, that mass gets converted energy or vice versa, then this is the energy which is released in the nuclear power generations and nuclear explosion as well. We'll talk about one of it, physicist that has been your Sir C.V. Raman from 1888 to 1970. Okay, so Sir C.V. Raman from 1888 to 1970, we talk about it. Here, that is your Chandrasekhar Venkata Raman, and that is was born on 7th November 1888 here. So we go for the Sir C.V. Raman in 1888 to 1970 here. So Chandrasekhar Venkata Raman was born in 7th November 1888 in that is your Thiruvannamalai, and that he finished his schooling by the age of 11. He graduated from a Presidency College, Madras, and after finishing his education, he joined Financial Services of Indian government. While in Kolkata, he started working on his area of interest at Indian, that is your Association for Cultivations of Science, founded by Dr. That is been Mahendra Lal Sirkar. And that is during his evening hours, his area of interest included vibrations, variety of musical instruments in ultrasonics, with the same here, and that what we'll have to talk about it here about, and that he graduated the presidencies of the government, and while in Kolkata he started, as I told you, in the area of the interest as the Indian Association for the Cultivation of Science, that founded by Dr. Mahendra Lal Sirkar during the evening hours, his evening hours. So his area of interest included vibrations, variety of musical instruments, ultrasonics, and diffraction, and so on. In 1971, no, sorry, in 1917, he was offered a professorship at Calcutta University. In 1924, he was elected as Fellow of the Royal Society of the London and received Nobel Prize in Physics in 1930 for his discovery as well. So, on the same phase that we talk about it, and now known as Raman's effect as well. And so the Raman effect that deals with scattering of light by molecules of medium when they are they are excited to vibrational energy and level, and the swags opened totally new avenues for research for years to come as well. He spent his later years at Bangalore and first at Indian Institute of Science and then at Raman Research Institute. His work has inspired the generations of young students as well. And on the same phase, they talk about here in the about in detail that the energy is a scalar quantity, but all conserved quantities that are not necessary scalars, and the total linear momentum and the total angular momentum, that are both vectors here of an isolated system, that are also conserved quantities. These laws that can be derived from the Newton's laws of motions in mechanics, but the validity goes beyond mechanics. They are the basic conservations laws of natures in all domains, and even in those where Newton's laws may not be valid. Beside their great simplicity and generality, the conservations law of nature that are very useful in practice too. It often happened that we cannot solve the full dynamics of the complex problem involving different particles and forces as well, where the conservations law that can still provide useful results. For example, we may not know the complicated forces that act during a collisions of two automobiles, yet momentum conservation law that enable us to bypass the complications and predict or rule out possible outcomes of the collision in nuclear and elementary particles phenomena, that have also been the conservation laws, and that that are important tools of analysis as well. Indeed, using the conservation law of energy and momentum for beta decay, that has been the Wolfgang Pauli for momentum of beta decay, for momentum of beta decay from 1900 to 1958, that correctly predicted in 1931. Okay, and that the existence of the new particles that is now called as neutrino, that emitted in beta decay along with the electron. We are conservation laws that have a deep connection with the symmetries of nature that you will explore in more advanced courses in physics as well. For example, an important observation is that the law of the nature do not change with time. If you perform an experiment in your laboratory today and repeat the same experiment on the same object under identical conditions after a year, the results are bound to be the same. It turns out this has been the symmetry of nature with respect to translation, that is, displacement in time is equivalent to the law of the conservation of energy. Likewise, space is homogeneous and there is no intrinsically preferred location in the universe. To put it more clearly, the law of nature that are the same everywhere in the universe, that you have to take a cautions that the phenomena that may differ from place to place because of differing the conditions at different location. For example, the acceleration due to the gravity at a moon is 1/6 that of the Earth, but the law of the gravitation is the same as on both the moon and the Earth as well. On the same phase that the symmetry of the laws of nature with respect to the translation in space that give rise to the conservation of linear momentum, in the same way that isotropy of space into intrinsically preferred directions is being spaced here, where underlies the laws of conservations of angular momentum, the conservation's law of change, and that being that other attributes of the elementary particle that can be referred to a certain abstract symmetries, and the symmetries of a space and time than other abstract symmetries that plays a central role in the modern theories of fundamental forces in nature as well. Where that you just go on ahead for the detail about the summary, so that can be your physics that deals with the studies of the basic laws of natures and that the manifestations in the different phenomena, where the basic laws of physics that are universal and apply in widely different context and condition as well. The conservations that laws that have a deep connection with the symmetries of nature, symmetries of the space and time, and the other types of symmetries that plays a central role in the modern theories of the fundamental forces in nature as well, where the scope of the physics is wide, covering a tremendous range of the magnitude of physical quantities as well, where the physical quantities that remains unchanged in a process that are called conserved quantities. Some of the general conservation laws in nature that include the laws of conservation of mass, energy, linear momentum, angular momentum, charge, parity, etc. Some conservation laws are true for one fundamental force but not this other, whereas the physics are the technology that are related to each other. Sometimes the technology give rise to new physics, at other times the physics generates new technology. Both have direct impact on society as well. There are four fundamental forces in nature that governs the diverse phenomena of macroscopic and microscopic world as well. These are the gravitational forces, that force, that the electromagnetic force, and the strong nuclear force and the weak nuclear force as well, where unification of the different forces that domains in nature is a basic quest that in physics as well. Talking about the conservation's law and physics. In conservation laws in physics, that conservation of energy, momentum, and angular momentum, charge, etc. are considered that to be a fundamental law in physics. At this moment, there are many such conservational law, and that apart from the above four them that are other which mostly deals with that quantities which have been introduced in the nuclear and particle physics as well. Some of the conserved quantities that are called spin, baryon numbers, and your strangeness, hypercharge, etc. But you need not worry about them. A conservation law in as a hypothesis that based on the observations and the experiment. It is important to remember that a conservation law that cannot be proved. It can be verified or disproved by the experiments, and an experiment whose results is in conformity with the law verifies or substantiates the law. It does not prove the law. On the other hand, a single experiment whose result goes against the law is enough to disprove it. It would be wrong to ask somebody to prove the law of the conservation of energy, because this is a law that is the outcome of the experiments experiences over several centuries, and it has been found to be valid in all experiments in mechanics, thermodynamics, electromagnetism, optics, atomic and nuclear physics, and or any other areas as well. In the same phase, some students that feel that they can prove the conservations of mechanical energy from the body falling under gravity by adding the kinetic and the potential energy at a point and showing that it to be done to be the constant as pointed out the above. This has been only verification of the law that not need is proof here. Now we go for the same some of the questions here, but we start discussing about these questions in the next coming class so that it will be helpful for you as well. And for the same, it will be ending it up, and it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than this, we talk about it, we had done your sociology and software engineering, even though we had done your chemistry for class 11 part 1 and part that has been part 12 class 12 part 1 as well, that has been unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 as well. And with the conversions to atom as well, we had done your ER diagram, we are dealing with English vocabulary, we are dealing with PHP interview questions, we are dealing with computer based numerical and statistical technique, which has been unit 1, unit 2 and unit 3 we are in, and we'll surely be completing that soon. After completing that, we'll start discussing many more subjects, which has been the chemistry we are dealing with for class 11, which we had started with for the redox reaction, that is of part 2 for class 11. And in terms of it, we had done your reasoning. In that we had done verbal reasoning, and in verbal reasoning we had done general mental ability and logic reasoning, and in non-verbal reasoning we had done series and logic classification, analytical reasoning, mirror image, water image, geometric figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule rejection, grouping of analytic figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set as well. In terms of quantitative aptitude, we have started with arithmetical ability. In that we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, surds and indices, percentage, profit and loss, ratio and proportion, partnership, and then we'll discuss many more. Coming towards physics part 11th part 1, which has been, we have started with unit 1, which has been the physical world. We had done what is physics, scope and excitement of physics, physical technology and society, fundamental forces in nature and nature of physical law as well. We'll discuss the questions in the next coming class, and even though we start with unit 2 as well, that has been the units and measurement. In that we have to cover up the introduction, the international system of units, measurements of length, measurements of mass, measurement of time, accuracy, precision, instruments and the errors in measurement, significant figures, dimensions of the physical quantities, dimensional formula and the dimensional equations, dimensional analysis and application. Unit 3rd is motion in a straight line, which is we have to cover up the introduction, positions, path, length and displacement, average velocity and the average speed, instantaneous velocity, speed, acceleration, kinematics, equation for the uniformly accelerated motion, relative velocity as well. In unit 4 we have to cover up the motions in a plane, which is in introduction, scalar, vector, multiplications of the vector by the real number, addition of the subtraction of the vector, graphical method, resolutions of vector as well. Vector addition, analytical method, motion in a plane with a constant acceleration, relative velocity in the 2 dimensions, projectile motion, uniform circular motion. Unit 5 we have to cover up the laws of motion, which is in the introduction, Aristotle fallacy, the laws of inertia, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conservation of momentum, equilibrium of a particle, common forces in mechanics, circular motion, solving problems in mechanics. Unit 6 is work, energy and power, which is the introduction, notion of work, kinetic energy, the work energy theorem, work, kinetic energy, work done by variable forces, the work energy theorem for the variable forces, the concept of potential energy, the conservation of mechanical energy, the potential of the inner spring, various forms of energy, the laws of the conservation of energy, power and collision. Unit 7 we have to cover up the system of a particles and rotational motion, that is being introduction, center of mass, motion of the center of mass, linear momentum of a system of a particle, vector product of the two vectors, angular velocity and its relation with the linear molarity, torque and angular momentum, equilibrium of a rigid body, moment of inertia, theorems and perpendicular and parallel axis as well, kinematics of the rotational motion that about the fixed axis, dynamic of the rotational motion about the fixed axis, angular momentum that in the case of the rotation about the fixed axis, rolling motion as well. Unit 8 is your gravitational, that is been here. For the gravitation, it has been introduction, Kepler's law, universal law of the gravitation constant, acceleration due to the gravity to the earth, acceleration due to the gravity below and above the surfaces, gravitational potential energy, escape the speed, earth, satellite, energy of the orbiting satellite, geostationary in the polar satellite, and weightlessness as well. So here we gonna end up with thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe to our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.